Hello Brain Shakers, welcome to the Brain Shakers Academy. Brave Alice is here. Now, having looked at the process of fertilization, we know what happens when the ovum has then been penetrated by the male spermatozoa. Then you end up having a zygote. Now, the process doesn't just end at zygote stage, meaning that the zygote now will have to continue to undergo processes or mitotic divisions in order to develop into an embryo and then later a fetus before you can have a baby at delivery. Now let's quickly look at today's topic, which is the process of embryo development, which is under the terminology embryology, or rather the study of how the embryo becomes an embryo. So this whole process happens between the 3rd and the 8th week. So it occurs between 3rd and the 80th week. So it means that at the end of 8 weeks or at the end of 2 months, all the major structures and systems would be visualizable and would be functional at this stage. So this is the timeline for embryo development. Now, what happens after you have a zygote? So clearly you're going to have a zygote there, and because you have the zygote in there, there's a cell that has to undergo mitosis. So it means that the parent cell will give 2 daughter cells. So there will be 2 daughter cells that will result from this zygote. The 2 daughter cells also undergo further mitosis and give each 2 daughter cells, meaning that you're at the 4-cell stage. So you're at 2-cell stage, 4-cell stage, and then you go to 8-cell stage, you go to 16-cell stage. Now, when you reach a 16-cell stage, that is the stage that we call the dividing cell as a morula. Okay, so that is a 16-cell stage. So the process then continues. Now, as the process goes on and on, what is then going to happen is that there will be appearance of a fluid-filled space. So this fluid-filled space is what we are now going to refer to as the blastocyst. So it makes this become a blastocyst. Why? Because it is going to push some of the cells to one pore of that particular cell, and then the rest of the cells remain on the edges closer to the zona pellucida. So you still have the zona pellucida around here. It is obviously going to degenerate, and then what is going to happen now is that these cells, because it has changed its name, and this cell is now known as a blastocyst, because these cells, each individual cell is a blastomere. Okay, so you have this blastomere. Now, because there's a presence of a cavity and fluid in there, it is a blastocyst. Okay, and then you have the zona pellucida there. So pushing the cells to one pore or one end, then you have what we will refer as the inner cell mass. Okay, so once this has happened, this blastocyst continues then to increase in size, meaning that the fluid in there continues to increase in size. And as it increases in size, then it will have to hatch from this zona pellucida. Okay, so it breaks down from the zona pellucida and then gains access to the endometrium. Now, what was the trophoblast here is what is going to then culminate and develop into the 2 main layers, which we're going to call the syncytial trophoblast and the cytotrophoblast. Now, the cytotrophoblast has actively or mitotically active cells as compared to the syncytial trophoblast. So all that is going to emanate from the trophoblast, or the cells that are around here, which we are calling the trophoblast. Okay, now from the trophoblast you have the inner cell mass. The inner cell mass, once this particular cell has now gotten access into the endometrium, then we'll see that the inner cell mass is what is going to develop into what we refer to as the embryo proper. Okay, so we will call that the embryo proper. It means that that is where the embryo is going to emanate from the inner cell mass, while as the cells on the outer part, which is the trophoblast, will then differentiate into the cytotrophoblast and the syncytial trophoblast. So once it has gained access into the uterus and gains access to the endometrium and then completely buries itself into the endometrium, you find that it will bury itself closer to the uterine glands, so that the uterine glands then continue releasing their supplies for the whole process of nidation or placentation to continue, and then facilitate a good uteroplacental unit, and also make sure that this pregnancy does continue to term. So you have uterine glands here. This is the endometrium, and then it buries itself right into the endometrium, and then there'll be a fibrin plug that is going to form there where it did gain entrance into. So what we did have here as the trophoblastic layer now comes here and differentiates and forms what is referred to as the cytotrophoblast, which is the cells here that are mitotically dividing cells. And then around the cytotrophoblast, you now have the syncytial trophoblast. Now let's begin with the syncytial trophoblast and see what happens. So the syncytial trophoblasts are very cardinal in making sure that they invade the spiral arteries for the decidua. So as they invade the spiral arteries for the decidua, they make them more flaccid, and then there will be more blood that is actually coming into those spiral arteries, because there will be remodeling that is going to happen in these arteries. They are usually spiral, but then once they get invaded and some of the epithelium is actually replaced, then they change from being spiral to more flaccid vessels that then bring adequate supply to the uteroplacenta unit. So you will notice that there will be vacuoles that will appear within the syncytial trophoblast, and it is these vacuoles together with the lacuna where the maternal supply is going to pour into this, and it's a connection now of those lacuna and the sinusoids that are in there to form the uteroplacental unit, meaning that from the uterus then there is a supply to the placenta that is going to form, so that then the growing fetus will benefit from the supply that is coming from the unit that has been formed. Now, we did mention that we are going to have an embryo proper, and that is emanating from the inner cell mass. So we did have cells that were ramped up in one end. So these cells that were ramped up in one end, what is now going to happen is they will begin to differentiate, and as they differentiate, they form what we call a bilaminar disc. From bi, it means that they form two. So what is going to happen is you have cells that will form around this region, okay? So these cells form around this region, and the ones that form on the upper part are going to be more columnar than the ones that appear on the bottom. So on the upper part, you have columnar cells. Okay, and then on the bottom part, you're going to have what we refer to as cuboidal cells. Now, the columnar cells are what we are going to call the epiblasts. The cuboidal cells are what we call the hypoblasts. So epi is on top, hypo is just right below. Now, as this is going to form, what then happens is that, again, a fluid-filled space begins to appear right within the epiblast. Now, as it appears within the epiblast, what is going to happen now is that it is going to obviously push some of the cells. So these epiblasts that do form are continuous with the amnion this side, okay? So they are continuous with the amnion, and then a space begins to appear here, which is the space that we see here, and then this will culminate into what we refer to as the amniotic cavity. Okay, amniotic cavity. So these cells that are here on the upper part are now referred to as amnioblasts. Now, amnioblasts are very cardinal in the production of amniotic fluid as well, which is obviously the fluid that the baby is going to be in, which we call the liquor amni. Now, we have our epiblast here, and then we have the hypoblast. So the hypoblast would then be continuous also with the exocoelomic membrane. So you have the membrane that forms right down at the bottom here, being referred to as the exocoelomic membrane. And the exocoelomic membrane and the hypoblast form now the lining for the primary yolk sac. So together the amniotic cavity and the primary yolk sac help then in the development of the structures. So you have the epiblast and your cuboidal hypoblast. Now, what is going to happen thereafter is that just on top of the epiblast, there is then going to be development of what we call a primitive streak. Okay, so a primitive streak is the beginning now of the formation of that the structures themselves. So it will appear more or less like a groove that will appear with more or less like a head like this, and then you call this the primitive node. And then in between here, you're going to have what we call a groove. Okay, and then this whole thing is now referred to as the primitive streak itself. Okay, so if you are looking at it, if you do a cut here and then look at it from this direction, what you're going to now see is that you're going to have those epiblasts and you're going to have hypoblasts on the bottom. Now, as you're having hypoblast on the bottom, what is also going to happen now is that the process of invagination then happens, which is going to stimulate some of the epiblasts to push the hypoblasts down. So, as the hypoblasts are being pushed down, the cells that are going to appear closer to the hypoblast are now going to be referred to as the endoderm. Then the cells that remain on the top part of the epiblast are going to be the ectoderm. That means the cells that will be in between the ectoderm and the endoderm are now going to be called the mesoderm. Okay, so these are the three germ layers, and the formation of these three germ layers is a process that we call the process of gastrulation. So the epiblast gives rise to all the three germ layers, and it is from these three germ layers that all these other structures are going to emanate from, all the systems are emanating from. For instance, if you're talking about the ectoderm, you have the hairs, the nails, all those, the central nervous system emanating from the ectoderm. If you're talking about the mesoderm, then you're talking about issues to do with the bones, cartilage, that is the muscular and skeletal system as well. If you're talking about issues to do with the endoderm, then they'll give you the lining of things like the bladder. And then these now form the other structures, and so all the other structures that are going to develop during human life are going to emanate from the three germ layers. All the three germ layers then come from the epiblast. So basically, that is what happens with the process of embryology. Now the development continues. All those structures and systems that have been developed by the 80th week then will now just begin to mature, and then you have a functional fetus that can respond to different stresses, and then eventually we'll have a pregnancy continuing until we are at 40 weeks or 40 plus or below 40, depending on the time that the woman does deliver, and then you have that baby or the neonate being delivered. So basically that's what happens during the process of embryology in simpler terms. Now, if you did find this particular video helpful in trying to simplify the whole process of embryo development, which happens between the 3rd and the 80th week, please give me a thumbs up, drop me comments in the comment section. I would like to hear what you think, and I would like as well for you to subscribe to my channel so you do not miss any of those content that we're going to be sharing with you guys on our channel, which is the Brain Shakers Academy. And as always, it's a pleasure to have you here, and thank you so much for watching, and I will see you in the next one.